Hello everyone, welcome to physics class. Have you ever marveled at the sleek design of a smartphone or the breathtaking visuals on a high definition TV screen? Have you ever wondered how these magical devices work? Join me on a journey into the fascinating world of basic electronics, where we will uncover the secrets behind the devices that shape our lives and the circuits that power our modern world. In this video, I will explain to you the fundamental concepts of basic electronics and the most important building blocks of electronic devices such as computers, smartphones, televisions, etc. And that is what? That is the semiconductors. Learning outcomes. What are we expecting to learn in this lesson? By the end of this lesson, you will be able to explain electronics and basic electronics, define a semiconductor, compare semiconductors with conductors and insulators, identify the charge carriers and bond in semiconductors, and explain semiconductors' nature using the energy band theory. Electronics. Electronics is the science of controlling or manipulating electrons and other charged particles. Basic electronics refer to the fundamental principles and components involved in the study and application of electronics devices and circuits. Semiconductors. What is a semiconductor? A semiconductor is a class of material whose electrical conductivity lies between that of a good conductor and a good insulator. Examples of semiconductors. There are quite a number of them, but the two main examples are silicon and germanium. Now, let's discuss the electrical properties of conductors, insulators, and semiconductors. Let's compare them. Conductors have low resistance, and so they allow large electric current to pass through them. Their temperature coefficient of resistance is positive, and that means what? That means as temperature increases, the electrical resistance also increases. That's what we mean by their temperature coefficient of resistance is positive. And they usually have 3 or less valence electrons. Insulators. Insulators have high resistance. They allow little electric current to pass through them. Their temperature coefficient of resistance is negative, and that means what? It means as temperature gets higher, resistance gets lower. Then they usually have 5 or more valence electrons. What about semiconductors? Semiconductors have high resistance only at very low temperature. They have, they allow greater electric current to pass through them at room temperature. Then their temperature coefficient of resistance is negative, just like that of insulators as well. And they usually have 4 valence electrons. So that's semiconductors for you. What are the charge carriers in semiconductors? The charge carriers are electrons and holes. And of course, you know what electrons usually stand for: negative charges. The holes means what? Positive charges. And what about the bond in semiconductor? Semiconductors are tetravalent atoms. They form covalent bond by sharing one valence electron with each of four surrounding atoms. Now let's explain all solids with the energy band theory. In any solid matter, there are three energy bands, namely the conduction band, the valence band, and what? And the forbidden gap or the energy band. In a conductor, the conduction band, which is usually empty, and the valence band, which is usually filled with electrons, they are very close or even overlap, as you can see here on the diagram. So there is a considerable number of electrons in the conduction band, and when an electromotive force is applied, the free electrons move and hence current flows. In an insulator, the forbidden gap is wide, so wide as you can see, and so the valence electrons cannot easily move into the conduction band. Therefore, insulators do not have free electrons in their conduction band. And that means whenever electromotive force is applied, there is no free electrons to move and hence no current. But for semiconductors, they have narrow, look at it, they have narrow forbidden energy gap. So they have few free electrons, the very few electrons who can cross the narrow forbidden gap. There are few free electrons available in the conduction band at room temperature. Thus, semiconductors are neither good conductors nor good insulators. What are the kinds of semiconductors that we have? There are two kinds. One, pure or intrinsic semiconductors, and two, impure or extrinsic semiconductors. What do we need to know about the pure semiconductors? At room temperature, they have equal number of holes and electrons. Both holes and electrons, both the carriers, they are very few in number, and the conductivity is very weak, and the drift velocity of electrons is greater than that of the holes. What about the impure semiconductors? In order to increase the number of holes and or electrons so that the conductivity of a semiconductor could be increased, a particular type of impurity is deliberately introduced, and this results in an impure or extrinsic semiconductor. Yeah, so far so good. Take a moment to perform this class activity. Welcome back. Now, in conclusion, what have we discussed in this lesson? In this lesson, we have explained electronics and semiconductors in details. We have distinguished semiconductors from conductors and insulators, and we have classified semiconductors into intrinsic and extrinsic groups. So far, so good for today. When next we meet, we'll be discussing impure semiconductors in detail. But just before then, note down this assignment. So that's it for today. Join me in the next class when we'll be discussing impure or extrinsic semiconductors. Till then, bye bye for now.